Caffeine is seen as the most popular drug, and like the rest of the world, I wake up with my morning caffeine hit.
Caffeine is very important to me and is part of my regular day-to-day life. Caffeine gives me that extra energy throughout the day and helps me get to those unwanted morning lectures. Caffeine is a naturally occurring molecule which acts on the metabolic and the central nervous system. Small doses of caffeine can make you feel refreshed and focused, increasing alertness. However, in large doses, you are more likely to feel anxious and have difficulty sleeping.
The molecular formula of caffeine is C8H10N4O2. This means a single molecule of caffeine contains 8 carbon, 10 hydrogen, 4 nitrogen, and 2 oxygen atoms. This gives caffeine a molecular mass of 194.19 mole. Here is a model of the caffeine molecular structure. Each atom is displayed in a different colour to separate the differences between each atom. Orange, carbon; blue, hydrogen; pink, nitrogen; purple, oxygen. The caffeine molecule is very stable and it contains 2 rings. Caffeine is a tricky molecule when discovering its polarity. The substances can be dissolved in water and has both polar and non-polar bonds. However, caffeine is a polar molecule. This means the electrons are shared unequally and are closer to the more electron-negative side. The polarity of the molecule is crucial to the properties of caffeine. The polarity can affect the taste, smell, solubility and melting point, which is 235.3 degrees Celsius. The bonds between the hydrogen and oxygen are non-polar bonds. However, the bonds between the carbon and nitrogen and the carbon and oxygen bonds are polar due to the differences in electronegativity. There are 4 double bonds present in the structure. Double bonds show that there is a sharing of 2 paired electrons. The sharing of 2 pairs of the electrons means that there is a covalent bond which provides more stronger and reactive bonds in caffeine. Covalent bonds make up the intermolecular forces within caffeine. There are 2 carbonyl bonds present within the molecule, implying covalent bonding between carbon and oxygen atoms. There is also an imine bond between the carbon and nitrogen atom.
When caffeine is consumed, it travels around the body to the brain, where it inhibits the function of adenosine. Adenosine plays a major role within the body in regards to energy transfer. The chemical adenosine binds the adenosine receptors in the brain, which causes drowsiness by slowing down the nerve cells' activity.
Caffeine and adenosine have very similar chemical makeups. They both have the same ring structures. This is why caffeine can effectively block adenosine receptors so adenosine cannot attach. Therefore, the nerve cell mistakenly selects caffeine instead of adenosine.
Because adenosine cannot attach to the receptor, the speed of the neurotransmitters increase, enhancing the nerve's activity, causing the brain to become more alert.